Okay. Hello and welcome to my little talk about how computers became home computers. So, everybody knows his personal story about his first computer. For me, it was the C64, for example. But my parents told me that there was a time when there were no computers at home. So, I've wanted to do some research on how the computers came into the home. And for this, let's just assume it's 1974, and we've noticed with a few friends who realized that something is coming up. Now, the first microprocessors are available for buying, which makes building a computer much easier, going from those TTL-based mini computers into a full-fledged microcomputer. And we now all, as a group, decide to form the Electronics Enthusiast Club with the idea that we want to learn about how we could build our own computer and maybe also come up with things that we encounter over time in a discussion, something like monthly meetings. So this is now what I want to do here is to pull out some highlights from our monthly meetings. And I've got a full disclaimer on this one. This is not a full review. The machines have been picked by me just to get an overview. There are much more than this in this time. And also, I'm too young to be really one of the ones sitting in the trenches, like the old guys telling their stories. I had to research it, so it's not firsthand. And also, I'm a bit biased on the selection of machines that I've got. I'm 6502 guy. So, in 1974, if you want to play with computers, all you could do is get a job that involves computers, mini computers, that is. However, now starting in 1974, in March and April, Motorola and Intel have introduced two choices of microprocessors that you could buy with an introductory price from 360 euros. But the processor isn't everything. We also need other stuff like RAM, ROM, I/O. We need to make our own PCB, and something that's often overlooked, we also need to build our own power supplies. You cannot go in the store and just buy a power supply that gives you a wonderful 5 volts. You have to build something like that yourself. So, while we are trying to figure out how things are working, in 1975, in January, something gets announced. This is the MITS Altair 8800. MITS stands for Micro Instrumentation and Telemetry Systems. So a full kit gets sold for a price that's slightly over the processor. How is this possible? It is possible because Ed Roberts, the chef of MITS, was able to negotiate a contract with Intel that he buys the processor in OEM quantities and now gets them for just $75 a piece. However, this machine becomes such a success that MITS itself could not handle the demand, so clones came up. And what we've got is a machine that's got an Intel 8080 processor, and we only have 256 bytes of RAM, not even a single byte of ROM. If you want to do something with the machine, you have to click in the code into RAM by stopping the CPU and then driving the lines by hand. This is also how bootstrapping the mini computers were done, so this is not that unfamiliar at this time. Also, this machine has a modular design, so it's easy upgradable, or rather easy upgradable, for example, by RAM, just by adding a board. And also the machine had the origin of the CP/M operating system, so this is the machine CP/M was originally coded for. And also interesting is the expansion bus of the S100, which it was called, which is mostly just a processor bus put on a connector. So this is what this machine looks like. Big front panel where you can then stop the machine, click in your code. So first you use the 16 switches to click in the address, you register that, and then you go into a data mode where you can toggle in then the data. You can also watch what is happening, so the LEDs are turning on to display play the address and the data that's available there. And what I think what's a really interesting part about this is they are grouped in threes, not in fours. So this machine really thought of the data you input not as hexadecimal, as most of us are now accustomed to, but octal. And this is what the machine looks from the inside, and here you can see some already add-on boards put in there. Here's the slot of the S100 bus. So, and here you can see the front, so that's really some hefty machine. Then another guy from our group comes up. Look what I found. There is something similar done with the Motorola 6800 that was done with the Altair. So he came up with a machine that's around the same price and comes with a Motorola 6800 CPU. It has 4K of RAM, which is quite interesting, and also 2K of ROM. But it has a downside. The downside is that a terminal is required to use this. And at this time, the terminal costs at least, even used, twice as much as the computer itself. So at this time, our club decides for testing purposes and so that also people come, our club buys a common used terminal so that we have got something we can connect our machines to, and that we can also test them out before we then go out and try to find a terminal. So this is what the machine looks like from the front. It's really just a power and a reset switch. It came, as all the computers back then, with a nice manual. And here you can see it has a big power supply built in. And it has a processor board, a memory board, and it has an I/O board. So, and this I/O board is then our serial line, which we can use to log in. And now, I've got to sit down, because right now I've got something to tell you that our club at this time is not able to know. So I'm doing a short intermission. In later 1975, MOS technology introduced the processors 6501 and 6502. They are claimed to be, and they are, signal compatible to the Motorola 6800. So what you have learned from building a 6800 computer, you can also now use to build a 6502-based computer. But the really revolutionary thing is that for a single CPU, you only have to pay $25. And behind the scenes, then something happened. Atari was interested to use the CPU for creating a games console. They had the target price of $200, and they negotiated with MOS that they would buy a combination of an embedded version of the CPU, which has a reduced feature set, but in terms of connectivity, and also something like a one-chipset, which would do some of the RAM, or the RAM, or do the I/O, and all of this for a bundled price of $15. But there was a very big problem that Atari had. MOS was just something like a startup, you would call it today. What if MOS goes bankrupt? So as part of this deal, MOS licensed the design to other companies like Synatec or I think Ricoh as well. So, and from the fair where I went and bought one of the CPUs, I also need to buy a companion chip that would provide me with much of the stuff that I require. ROM, RAM, I/O, and even a timer. And you can really think of it as a one-chip chipset. So what we've got now here is a die shot. And just to give you a perspective, this is the ROM area, this is the RAM area, this is the I/O area, and this is the timer area. This is the other way around. Timer's at the bottom, and this is I/O, yes. And on the sides, you've got all your connectors. The top up here is address decoding logic. So you could, when you buy one of those chips, you could order it with your custom ROM mask, and you could also order it with the configuration on how the chip should be mapped into memory. So you could buy just 3 chips with different content and put them in on the same bus, and they would decode to a different address, and so you could spare on the address decoding logic, so you could save on this one. How much ROM is this? You could really tell from the die shot. You see that these are roughly something like 8 small things, so this is most probably a byte. These are 2, 4, 6, and another 2 on the edges, so these are 8 bytes. And if you count down the lines, you get something like 128. So this is 1 kilobyte of ROM. On the side, we've got the RAM. And this is something roughly a surface area from 1.5 to 1. Let's have a guess. How much of RAM is this? So if you say 4 times less, so that's 256. One of those things is a whole flip-flop. So this is really just something like 64 bytes. So this is why RAM was so expensive back in the days and ROM was rather cheap. It's SRAM, yes. So, and when I was now getting back from the fair, trying to build some things with some chips, Linus comes up with, yeah, already somebody has done the work for you. There's a computer available that already uses what you bought on the fair, the CP6502 processor, the RIO chip, and even an additional I/O controller, which is, as you can see, by 68, rather intended for the Motorola. It also includes 512 bytes of RAM, plus the 64 we have from the I/O chip. We have got our 1 kilobyte of ROM, and also this one requires a terminal for user interface. So our investment in buying some kind of terminal has already paid off. Also, the machine was soon to be succeeded by the Super Jolt, but to me it's more something like a Jolt Plus. It increased the clock speed from 750 kilohertz to a megahertz, so there were just minor steps on this. This is what the machine looks like. So we've got our 3 chips with the processor, the I/O, the RIO chip, and the additional PIA, parallel interface adapter. And this is our RAM, and the rest is a bit of address decoding logic. So this is a very, very simple computer. However, it is a computer that comes even with a TIM machine language monitor, so that you can have something where you can type in stuff. Although it's not a machine language, it's just a monitor where you can watch some memory and edit it and run it. So this is now our short intermission. The interesting part about the Jolt computer is that it was used to develop the Atari 2600 again. So I should be sitting down. However, you can see an early prototype of what the machine is in there. So you've got some pedals, you've got your joysticks so that you can use it. And the rest was then added to the machine itself by the buses that were available on this thing. Shortly after that came something was released that most people now think of as the first 6502-based computer, but we've just seen it's the second, not the first one, which is the KIM-1. And this is something that comes in an assembled price of $250 roughly. The interesting thing about this is you're really getting, today you get something like an evaluation platform. So you get, not only if you buy a processor, you get a full platform where you have some I/O in it and stuff like that. You can think something maybe like just like a Raspberry Pi or so. And this is one of those machines, a machine that really allows you to fully develop your own application using the KIM as a basis. The interesting part about this is, even though it supports a terminal, it is not required because it has a very basic interface where you can type in hex stuff in a calculator-like interface, and this looks something like this. Of this whole setup, very interesting is this little switch. It's not the power switch. It is a way that allows you to get your machine into single-step mode. So this is what really fascinates me about this machine. It enables you to run your code an instruction at a time, and you can follow by the address counter, which is stored here. Here's the data counter. You can see how the machine progresses through your code, one step at a time. And then our guy who came up with the first MITs, he was building his own RAM boards. So he could use the RAM boards to sell them and to earn some money. And he invested this money in his next computer, which is a SvOlli, which is a machine that, as you can see by the expansion bus of the S100, which is a clone. But this thing is really interesting in terms of, it was originally intended that's by somebody who wanted to build a terminal for the MITS, or for the Altair machine, and then decided, yeah, let's just put the Altair inside the terminal as well. And this is really one of the first times something like what we imagine of a home computer really came to be. A machine in a case together with a keyboard, and where you can just power on and type on into use. Here also you can see the bus, so the RAM expansion card that our friend built is also in there, or can be included in there. And then, I think the machine you all been waiting for, the legendary Apple I, which was similar to in the design to the KIM, but for a big change. As a user interface, now full terminal was required. You only needed a keyboard and a CRT. So the whole logic of which character to print where was done within the machine. So if we take a look at the PCB, also interesting, so before I go to the ROM, only 256 bytes, which just contained the WASMON, the monitor most enthusiast 6502-based computers port over on a new architecture if they really want to have something really basic that they can work with. So, and this machine is fine. You can almost split it in half here. The upper half is the display circuitry. The lower half is the computer part. And it also comes with some kind of simplified power supply already. You still need to have, you couldn't plug it into the wall. You still have to have a power supply in between, but however, it worked. And now I also want to go about a thing that I've heard a lot of times, that the 6501 is the same as the 6502, except for a different pin layout. This is not true, because this machine was also designed to run with the 6800, but for the 6800 only, you needed to do some supply some additional clock circuitry. So the 6502 is more advanced. It already saves you on building your own clock circuitry. It is already in the chip itself. And also the fun part about this is, why this didn't become a 6800 machine was asked for at Motorola for some chips so that he could also customize the machine working on this one. And Motorola just stated, too low amounts, we don't want to deal with you hobbyists. We don't sell any of the chips to you. So, now I have to sit down again, because we are now coming to the most interesting part of the behind the scenes. MOS as a startup was getting, due to some business practices, also due to Commodore, getting into financial trouble. So Commodore then went out to buy MOS technology. This was a big problem for Atari when they were developing their games console. Because Jack Tramiel, the CEO of Commodore, is known as a very ruthless businessman. So what if Commodore and Atari became direct competitors for something like a home computer or a games console or whatever, and Jack Tramiel just decides to cut off the supply of the chips to drive a competitor out of business. So Atari had some leverage there. One of the leverages was that they were about to buy 100,000 of the Atari 2600. I've heard that the first year, so just from something like October, when the selling of the 2600 started, up to it was 1977, so up to the end of the year, 400,000 of the game console were sold. So this is a huge amount that Jack Tramiel really wanted the money. But also, what Atari did, that was they created their version of the 2600 based on the 6800 from Motorola. So the big problem there then was that the machine with the 6800 was way too slow to do what they intended to do with the 6502. However, they could claim they have a working prototype of the Atari 2600 that was running, that could run some software. They could say, okay, Jack, we've got our prototype working, we could also use the Motorola one. So then they came up to the conclusion that the second level source could never be shut off by Commodore. So if Commodore doesn't want to do business with Atari anymore, they could buy one of those competitors of MOS or who has licensed the design, like Xenatec, Ricoh, for example. So this brings us up to the Trinity of 1977, starting with the personal electronic transactor. A machine that was, with the $800, really a fair price, came with 4K of RAM, and which was a huge thing, with a Microsoft Basic interpreter based in ROM. So that you could turn on the machine and do much more of it just with a machine monitor. And it also it was looking something like a full terminal with a monitor and a keyboard. And about the keyboard, well, Jack Tramiel insisted, since they were building calculators and they had a lot of calculator keys lying around, that the keyboard needs to be built based on those keys. Because he was also imagining that it wouldn't be that much in use anyway. However, at one point they revised this whole idea and put in a keyboard that's way better. The second machine that we've got in there is the Apple II, which has a much steeper price and was delivering a bit less, a bit more. So the first machines came out only with 2 kilobytes of ROM. It was later added also to 12 kilobytes because at one point Steve Wozniak realized that his idea with the Sweet 16 virtual CPU that he had invented as an addition and implemented in software, as an addition to enhance the capabilities of the 6502 was something that people weren't really catching on to. So everybody else was using BASIC, so they decided, okay, let's put our own integer BASIC in there. Later on, they had AppleSoft BASIC, which was also a port of Microsoft BASIC. And they came up with a machine that's rather typical of what we know nowadays. It is a case, also something, this was one of the first machines that was a full plastic case. I think it was even the first one. You could easily connect some of those CRTs that were used for something like cameras that you could watch over some special areas, something like this. So if those weren't needed there anymore, you could buy them rather cheap and connect them to the Apple II. However, the Apple II had one more trick up its sleeve. It could do not only the black and white that those typical colors could do, but if you had something like a color display or maybe one of those new TVs that had a composite input, you could connect it to your TV and then get a whopping 6 colors. Done in a way with NTSC color artifacting in a way that's gruesome and ingenious at the same time. And then something rather new turned up. Tandy built a machine that was sold by Radio Shack, hence the name TRS. And it was based on a processor called the Z80. So what's the Z80? The 6502 was created by Chuck Peddle because he was unhappy with the way Motorola was selling their processors. He thought they had to be cheap, and he was really just not in tune with what Motorola was trying to do. So he quit and then went to this other new startup to complete these ideas of a chip there. The Z80 is roughly the same story on the Intel side. So Federico Fegin and Ralph Ungerman, they left Intel after working on the 4004 and the 8080 processors to form Zilog, where they licensed the design of the 8080 to improve on it and build a new processor. And this one was used then within the TRS-80. And it was a machine then also with 4K of RAM, 12K of ROM. So they are all very similar, but also different design. And this one was even slightly or similar to the PET. It came with a nice keyboard, nicer than the one of the PET. It was a bit, it was detached. And the monitor and the base machine, those was one unit. But this was one of the other nice computers that you could buy. And now, in 1977, at the end of those years, where we already had these exciting computers, there came out the first video game console that had the same design as those computers. Not like the Fairchild before it, which still had some parts that were typically done by the CPU included into the game cartridge. So this is really what you did to run a video game, is you had a computer in there and you just put in a new ROM as to have it run this game. Originally it was intended that the supplement of the game was done in the at the last step of the assembly line, so that you could buy a games console playing one game, another game console playing another game. But during development, they came up with the idea, yeah, why not make those cartridges that the customer can swap? And this is, the user interface then is back to a TV. some joysticks, some pedals you also had, and looking like this. But there's a big difference between this machine and what we use, we talked before about those computers. This can't display text. So if you want to have something like a text adventure on this one, like it was easy on the other machines, it's not possible there. This is also how the game Adventure came to be, which was the first game to have something like the Zelda-like game approach to a gameplay. Because he was just thinking about how can I translate a text adventure to this games console. So, faster than expected, I'm already coming up to my conclusion. Now let's take a look back. In just 4 years, we've come from our electronic enthusiast club, where we wanted to build our own computer or maybe learn on how to assemble some kits and stuff like that. Now we can, 4 years later, we can buy a computer in a store. We just can go in there, say we want a computer, put it on the table, plug it into the wall, and it just works. So I think, as head of our little computers club now arriving at the end of 1977, we should rename our club to the Computer Enthusiast Club now. However, we've got a small epilogue on this one. Even 4 years later, so the same time that it roughly took to get a computer into a usable state at home, we've got 4 years. 4 years later, so the same time span, then came out the VIC-20. That was marketed as a computer that can play video games like a console for a price that's competitive to the games console, not to the computers. It came with respective 5K of RAM, which is not much, but something you can still learn programming on. It came with a whopping 20 kilobytes of ROM. And it comes really in a shape that it's usable and uses now the available television sets as your display for the machine. So 4 years from getting from nothing to a home computer, and another 4 years from the home computer to a children's toy. This is what I think is really impressive about the speed at that time in development. And I also have to come up with an honorable mention. There was one machine that was before all that. That was called the Q1. And as you can see, in February of this year, when this talk was already done, I stumbled about this German news outlet for computer stuff, and they came, hey, the first computers were found from 1972. I was, what the? Huh? And then I tried to figure out something about this machine. The image that the news outlet used is a Q1, but this is a Q1 that has already a Z80 processor inside, and not the Intel 8008, the 8008, that was in the original Q1. And the original Q1 looked more like a typewriter with a one line of LED where you could see some text that you entered. So if I had an Apple I, I would like to trade in this one for the Q1. And I'm already now done, way faster than expected. But I have to give out a huge thank you, because when I was searching researching on all those old machines, it was typically like I found something on Wikipedia, 2 other sites, and when I was searching, at one point or another, I always came up to the website of Hans Otten with his retrohansotten.nl. I've been in contact with him, trying to figure out some stuff about, for example, the Jolt computer. He's a very nice guy to contact. So without his support and the material that he has gathered, I wouldn't have been able to do this talk. And also, another thing I wanted to thank is you participating here and all the other people who are as nuts as we are and trying to build those machines as well. So, thank you. However, if you would like to try out a computer, I've got a clone of the KIM-1 with me. This is the one that is slightly improved the way that I've got it. Also, those are Riot chips. They are no more precious than gold. Because they are, and this uses a slightly different design to come up with things. And so, and you can also, if you catch me walking around, I can give you an Arduino version of this one, which is just then printing out. If you want to learn the user interface of a very old computer, I can help you with that. And another thing that I did, I just want to shortly let you know. This was originally part one of a two-part talk that I did in August for our Chaos Computer Club in Hanover. And part two was about a very simple machine that I built using a 6502 processor and a microcontroller that does then the rest that this processor needs. So I call it also like the chipset, but it also includes the RAM, it does the clock, it does everything. This is a platform that's very good for giving you a deep insight on the 6502 processor. You can really figure things out, set up a test bed. You can even implement, like I did, an Apple I computer on this one rather easily. I'm now working on my own computer. It also has a bus, so it is expandable. And in parts, it is something like 10 to 15 euros if you buy the parts for 10 pieces. So it's rather cheap. If you want to learn about this one, I can also show you. I've got some with me. And we can sit together and I give you another lecture. And most probably there will be then a lecture next year about that machine as well. So, again, thank you. Are there questions? We've got somebody with a microphone here. Sorry. I thought I was already have answered everything. Then the stream also gets that where you use the microphone.
Okay, thanks for the presentation. If you look at the price of the computer you said, there are several order of magnitudes higher than Raspberry Pis of today.
Yeah.
Especially if we take into account the change of value of the money.
Yeah.
So who are the members of your association and what are they doing with these computers? Because there is no software with them. So they are ready to spend a lot of amount of money to do nothing with them?
Well, I can tell it now from my nowadays perspective. I'm also paying huge amounts of money for computers like an Apple II GS, which cost me something 1,500 in the condition that I've got it now. The intention on this, I would like to compare. Why are people working on old-timers, trying to restore them, having them work? It is a hobby. It is a hobby they can get something out there. Maybe once a year they take it out to buy some groceries or so. But typically they do use it for something else. I think in our club, it is really people who are into electronics, who were fascinated by the technology and wanted to come up with the ideas of building something. So, and with the introduction of Microsoft Basic, which was a huge game changer, it was really easy for a person to do something like business calculation. So, or maybe as an example, some guy working at mathematics could then come up with an algorithm to figure out the answer of a mathematical question. So it was really helping. It was getting the computational power from those 5 machines. There were, I know this famous quote by one of those, I think early IBM guys or so, there will be only a usage of 5 computers worldwide, when there were even before the mini computers. And look now, I think you've got more than 5 computers on you right now, if we take a look. So I think, and this is really the starting point of this, where you could get from, you have to work with computers, you can start it as a hobby. You can start it to learn and come up something. And like in my example, you can even make a business out of it, selling RAM expansions to other enthusiasts, for example.
Okay, thanks.
You're welcome. Any other questions? Come on. Just one. Yay!
It's specifically about the price tag for the first Apple computer. Wasn't it a bit disturbing that the price tag for the assembled one was exactly $666?
Yeah, that was the idea of Wozniak, because he liked to have the similar digits. And also, if you take a look in history, the 666, as far as I know, is a wrong translation. The real number of the beast is 606. No? Ah, 6 times 6. Okay. Okay. Anything else? Okay. Then I think I can get free of the microphone, and I'll see you around here.